Okay, these are the examples for Algebra 1A, Credit 3, Lesson 7.3. Lesson 7.3, we're going to be graphing inequalities. Graphing inequalities is very similar to graphing a linear equation. The only difference is we have to make a couple decisions towards the end, whether it's a broken line or a solid line, and whether we're going to shade above or below the line. So how do we know that? Well, let's run through our four different possibilities here. Greater than means we're shading above the line, but notice there's a broken line here because if it's greater than, our solution is only what's greater than or above the line, not including the line, so we indicate that with a broken or dashed line. Greater than or equal to means we're including the line, so we have a solid line, but just as it with greater than, whenever it's greater than, we're shading above the line. Our other two possibilities, less than or equal to. Less than, we're shading below the line, but if it's only less than, we're not including the line, and so we indicate that again with a dashed line. Less than or equal to means we have a solid line, and again, less than, we're shading below the line. All right, so let's take a look at how we graph this. We start out actually more than similar, the same way that we graphed a linear equation. Notice that this is in slope-intercept form as y is by itself. B is the y-intercept. The y-intercept is -3. So we're going to go down 3 on the y-axis and put a point there. Now we're going to find one more point using the slope. The slope is 4. So we're going to make that a fraction by putting it over 1. Remember, slope is rise over run. So from this y-intercept, we're going to rise 4 and run 1, meaning we're going to go up 4 units or 4 squares and then to the right 1. Now we're going to connect those points. Now with our first example here, we do have the equal sign, so we will connect those points with a solid line. So let's go ahead and do that. And so that would be a solid line. And again, that's because of the line underneath the inequality here. It is there, so that represents an equal sign. And notice this is greater than, so we're going to be shading above the line. Now, here we're just making some squiggly lines so we don't use up an entire dry erase marker. But in your packet with the pencil, you can shade that in very nicely as if you were drawing a picture there. And that's it. That's all you have to do to graph it. Now, the other thing that they're going to ask you for is they want us to give 2 ordered pairs that are solutions and 2 ordered pairs that are not solutions. All right, so there we go. Try and spell that right. There we go. All right, so points that are solutions would be anything on the line or in the shaded region. Well, let's be safe. We'll just pick points in the shaded region. So for example, from the origin, we can go 2 to the right and then 3 up. So -2 and 3 would be one example of a solution. And then we could go, let's say, let's go 5 to the left and 3 down. And let's go ahead and label these here. So this was 2 to the left, 3 up. This was 5 to the left and 3 down. And so that would be another solution because that's in the shaded region, -5, -3. So literally an infinite number of possibilities here. Any point in the shaded region would be a solution. We only have to identify 2, thankfully, not an infinite number. So again, -2 and 3, 2 to the left and 3 up, -5, -3, 5 to the left, and then 3 down. 2 points that are not solutions would be anything that's not in the shaded region. So let's say maybe, how about right here on the x-axis? That would be 4 to the right and just stay there. So that would be 4 and 0. Let's make that a little bit more clear. And how about, I don't know, let's do maybe 3 to the right and 2 up. And so that would be another point that's not in the shaded region, and that would not be a solution. So our graph with 2 points that are solutions and 2 points that are not solutions. All right, so that is it for example number 1. We're going to take a look at one more graph here. And let's see, just making sure there's nothing else we want to say here. Looks like we're good. Okay, yeah, that is it. All right, so that's it for number 1. And here is our example for number 2. Our example for number 2, we have y is less than negative 3x plus 5. All right, so once again, we start with the y-intercept, which this time is positive. So positive 5 would be up 5 units on the y-axis. This time our slope is a negative number. It's negative 3, but it's not a fraction, so we still have to put it over 1 to make it a fraction. Slope is rise over run. So from this y-intercept, now notice that our rise is negative, so we're going to go down this time. Our run is still positive, so we'll still go to the right. So from this y-intercept, we're going to go down 3 and right 1. So down 3 units and then right 1 unit and put a point there. We're going to connect those points. Now this time, there's no equal sign underneath the inequality. So when there's no equal sign, notice here and here, either case, we have a broken or dashed line. So let's go ahead and draw that. So that's the first decision we have to make, that it is a broken line because there's no equal sign. This is less than, so less than means we shade below the graph. So we're going to shade over here below the graph. All right, so once again, they want us to give 2 points that are solutions and 2 points that are not solutions. And so let's go ahead and do that. So again, solutions are any point in the shaded region. So how about, let's see, maybe this one right here, which that would be 4 to the left and 1 up. So that's negative 4 and 1. And how about something right on the y-axis? We did one on the x-axis. Let's do one on the y-axis. How about here at, so if we're on the y-axis, so the x-coordinate is going to be 0. We go down 3, that's negative 3 there. 0, negative 3. Our non-solutions, let's pick a point, I don't know, maybe here. So that would be 5 to the right and 2 up. So 5 and 2 would be not a solution. And then how about one down here, just to have something in the negative? Let's go maybe 6 to the right and 1 down. So that would be 6 to the right, 1 down. So that's 6, negative 1. 6 to the right, 1 down. That would also not be a solution because it's not in that shaded region. And oh, we didn't label this one, did we? So let's go ahead and label that one as 0, negative 3. All right. So our line is graphed with, we have the right type of line. It's a broken line because there's no equal sign. Less than, so we shaded below. And we've given 2 points that are solutions and 2 points that are not solutions. Let's make that a little bit nicer, and that one a little bit nicer as well. All right, so that is it for example for number 2, and that is it for our examples for lesson 7.3. Again, pause, rewind the video, because there's lots of little bits of information there. You don't want to miss anything, and do your best on the work, and we'll see you in the next video. Until then, take care, and God bless. Bye-bye.